Hello, welcome back.
Yes.
Okay. So just take a look at the index. What we have covered now is the expected returns, variance, standard deviation, covariance, and portfolio risk. So we've covered that part. And this is an important tool. This entire section that you've covered now in the second part, this everything is going to come back in portfolio again. So all these expected returns and variance and covariance and standard deviation, everything is going to come back again in portfolio in much detail. Now we are at the last part, which is a tiny part, and that is principles of counting. Now, many of these things you must have done during your graduation time period as well. So here, of course, the weightage is not too much to this, but we will learn the technique of doing it. And fortunately, we have everything right in our calculator. All the functions we have in our calculator itself. So before I go into detail of what this counting problem is and all, let me directly go to this example and connect you with that. So what is the example here? Here you are given number of ways in which 5 students can be arranged in one row. Let's say in a row there are 5 chairs. So you have to place these 5 students in a particular row, and in every student will be placed in a particular chair, correct? So tell me one thing, the first student, I have to place the first student. How many choices do I have for the first student? How many options does we have? So in how many ways I can place him up? 5. Why? Because I have 5 options with me. So first student can be placed in any of the 5 chairs. So I can say here that I will place in 5 ways the first student. So let's say I place the first student. I had the 5 options. After I've placed the first student, in how many ways can I place the second student? How many choices do I have?
4.
4?
5 into 4.
How about for the third student? For the third student, there are 3 choices left because the first 2 are placed. The second last student will have 2 choices and the last student will have only 1 choice, right? So overall, how many total ways are possible to arrange the 5 students in one row? That concept is called factorial. What is factorial? Factorial is a concept used. It's one of the counting concepts which we use to arrange a given set of n items. Here you have 5 students in a particular row or anything. So you are just going to arrange some numbers. However, here we did not arrange in a specific group. So some on the first bench and some on the last bench. So we did not have group. We just had to arrange 5 students in a row. Similarly, I can say I had to place 5 books in a shelf. How do I put them? How do I arrange them? So whenever the word comes arrange, you just arrange the n item sets. That is called factorial. So can you calculate 5 into 4 into 3 into 2 into 1?
120.
120 ways. And this 120 ways, guys, is called 5 factorial. 120 ways. This is called as 5 factorial and it is written like this. 5 factorial. The sign that you see, this sign is of the factorial. Everyone. Now, this function is already there in your calculator. But before I go ahead, what are we doing? We are doing counting problems. What are counting problems? These are shortcuts. These are shortcuts to count the number of outcomes which are possible. So the number of ways in which you can calculate these logical possibilities, that is what we call as the counting problems. So it will tell us the likelihood of observing a particular possibility. It is also a way to figure out the number of outcomes in a probability problem. And remember, there were 3 ways of calculating the probability: empirical, subjective, and the third one was priori probability. So that this is The logical reasoning, what we see here, this logical reasoning approach is nothing but it is the part of priori probabilities. So priori probability, I can say, is nothing but where you use the counting problems, or later on where we will be using permutations and combinations. That's all a part of priori, because empirical evidence is already there. Subjective is personal judgment. And then where you use this calculation, this is called priori way of priori probability. This is the approach through which you get the probabilities. Clear? Now, how do I calculate that quickly in the calculator? Guys, in your calculator right here, you have a function called x bar here in multiplication, right? Correct? That is nothing but the factorial function. So how are you going to do that? Guys, just press 5 and then press second multiply. 5 and then press second multiply. What is the answer on your screen?
120.
120. So that is the factorial. Correct? Everyone with me? Now, I just place the 5 students in a row. But what if they tell me that you have to place these 5 students, 2 of those students you have to place in row number 1. The other 2 you have to place in row number 2. And the last one you have to place in row number 3. Now, what is the difference between the previous example and the one that I'm dictating now? In the first one, you just arranged it randomly, right? Now, I am going to give you some category where you have to place them. Are you with me? I said you row 1, 2, 3, or let's say you have, you have 5 books. So I say which of the 2 books will be first best, the second best, and third best, and something like that. So what am I trying to do now? I'm going to give some category or some labeling. So in factorial, it's just arranging. What happens in labeling? In labeling, now you have the categories for everything that you have. Every n items will have categories. So overall items will be placed in some labels. Now, when I do this, we say from factorial, we now go to multinomial formula. And what is this? This labeling is applied when each element of the group, that is the entire n, is assigned a place or label. So here every element of the group has some category where they are going to be placed, right? In this case, what are we going to get? We are going to get a question where we are going to be told the number of ways that n objects can be labeled with some different forms of label. These labels are what we generally term as k. K will be the number of labels. So let's say here you have 3 different categories. So all those 3 different categories are 3 different labels. Now in each label you will have some item set from n. So let's say that n are 100. Out of that, 20 will be placed in one of the label, 30 will be placed in another label, 50 will be placed in the third label. So in that way we'll have different labels. Now before I go into the calculation and all, just to get factorial, you did n factorial. But now when you have label in the denominator, you will also have the categories and their factorial. Let me show you that. So what is the example of labeling here? In how many ways 5 stocks in a portfolio can be labeled in 3 categories. So out of those 5 stocks, you have to place 2 as buy, 2 as sell, and 1 as hold. Are you getting it? Had they just asked me in how many ways the 5 stocks can be arranged, then my answer would be 120 ways, isn't it? Are you getting it? Then my answer would be just arrange, right? No labeling. 5 factorial, correct? Everyone? But what's the unique part here? Compared to factorial, what is the unique part here?
Labels.
You have to label them. So actually there are how many labels do I have here, guys?
3.
3 labels, and each and every label has different output. So label 1, 2 buys, label 2 you have 2 sell, and label 3 you will have 1 hold. So here I have 5 objects. I will write, sorry, 5 objects, and I have 3 labels. Therefore, number of ways to label the n objects. How many objects do I have? 5. 5 stocks I have, right? How will I do that? So the formula is n factorial. That is the number of ways in which the stocks can be arranged divided by the category. The first category, that is 2 factorial. Why do I say 2 factorial? 2 will be buy, then the second will be to sell, and 1 will be hold. Are you getting it? This will be my answer. So in the numerator, I have the number of ways in which it can arrange, and in the denominator, I have the categories. Clear, everyone? Right? Now, you already know the numerator is 120. The denominator, if you solve 2 factorial, it is 2 into 1. So it is going to be 2 into 2 into 1. So you will have an answer here as how many ways? 30 ways. Correct? So there are 30 possible ways in which 5 stocks can be arranged as 2 buy, 2 sell, and 1 hold. I have now given label to the arrangement. Everyone with me on this?
Yes.
So can you try 12B and help me? What is the question? Suppose 10 bonds need to be classified in 3 groups. So you have 10 bonds which you have to classify in 3 groups. What are the 3 groups? 3 will be high risky bond, 5 is medium risky, and 2 less risky bond or low risk bonds. In how many ways can this be done? Can someone tell me the formula?
3 factorial.
In the numerator, it will be how much?
10 factorial.
10 factorial, correct? Divided by
3 factorial, 5 factorial, 2 factorial.
5 factorial and 2 factorial. Very good. So now what you will do first is that you can always solve the denominator and store it. So in your calculator, press 3 and then second multiply. So here you will do 3 second multiply, store 1, 5 second multiply, store 2, and then you have 2 second multiply, store 3. And then multiply all 3. Recall 1 times recall 2 times recall 3 equal to. Whatever answer you get, you can just store 4 or you can inverse it, whatever you want to do. You can just store 4. Now, in the numerator, you had 10 factorial. So press 10 second multiply. 10 second multiply. Whatever answer you get, divide that with recall 4. Divide that with recall 4. And let me know your answer. So 10 factorial divide by the product of the denominators. Anyone with answer? Should I show you the calculation, or guys, you have got the answer?
2520.
Then yes, correct. 2520 is the answer. Everyone, 2520. Right? So in only factorial, you are arranging the things. What is the unique thing in labeling? Apart from arranging, you're also giving them some category. Clear?
Yes.
So whenever you're giving labeling, you use the concept of labeling. If you're not labeling, you're just arranging, then it is 10 factorial. You're just simply using the factorial. Clear? Okay. Now tell me that we did covariance. Covariance is between how many stocks? The covariance combination is always between 2 stocks, right?
2 stocks.
Yes.
And I just told you all that if when we were doing covariance or correlation, I told you that if there are more than 2 stocks, how do I get the number of combinations of covariance or correlation? You recollect this? A, B, and C, and D, n minus 1 by 2. You recollect something, right?
Yes.
Now that concept is what we are going to do is permutation and combination. Now what is permutation and combination? First of all, let me tell you, let's assume that there are three stocks A, B and C. I want to make, out of three stocks, I want to make a combination of two. So how many stocks do I have, guys? Three, right? And I want to make a combination of two. Now that number of objects that you have is called n here, which is 3, and you are going to arrange in some combination here, which is called r, and here you are going to make the combination of two stocks. Am I correct, everyone? So if there are three stocks A, B and C, how many combinations are possible, guys? Tell me quickly.
3.
AB, BC and AC, isn't it?
Yes.
AB, BC and AC, correct? But what if I say AB and BA are not same, they are different? Then you can say there is also the combination of BA, CB and CA also possible, right? Everyone with me? So two things can happen. If the order is important, can I say AB and BA are both different things? If the order is important, I'll repeat, if the order is important, can I say AB and BA are both different things?
Yes.
In that case, we use something which is called as permutation. So if it is permutation, guys, how many ways are possible? If it is permutation, you have total 6 ways possible, isn't it? Why? Because the order is important. So here I will write, I will have AB, BA, AC, CA, BC and CB. All are different combinations possible. So what is permutation? Permutation is when the order of selection is important. But when the order of selection is not important, we use combination. And in combination, then order is not important. So I can say AB and BA are same for me, isn't it? Clear? So how many ways are possible when in combination? I can say there are 3 ways. But had this been permutation where the order is important, then how many ways? 6 ways. Now, how to calculate this? We have something whenever it is combination, we use something as a formula called NCR. N here is the number of objects. Here you have 3 stocks, and C is combination, and you are going to make a combination of 2 stocks. So you write 3C2. And how do you solve this? NCR is always solved as n factorial over n minus r into r factorial. So we do n factorial over n minus r factorial into the r factorial. This is combination. So if you do 3 factorial divided by 3 minus 2 is 1 into 2 factorial. So in the numerator you will have 3 into 2, in the denominator you will have just 2. So 2 will get cancelled, you will have 3. But permutation we write as NPR, which is in this case 3, instead of C I will say 3P2, which is nothing but n factorial over simply n minus r factorial. Are you with me? So you have 3 factorial in the numerator, and denominator 3 minus 2 is 1 factorial. So your answer will be 3 into 2 into 1 in the numerator. So that is going to be 6. Now, can you recognize the difference between combination and permutation in the formula? There's only one difference. Have you recognized that or not?
R factorial.
Perfect. R factorial is the only difference. And where do you see the answer is bigger always? In permutation or combination?
Permutation.
In permutation, because the order is important, so there are more ways of doing. Clear? Now, what are we doing? In In factorial, you arrange the things. In labeling, you arranged in a category, right? But permutation and combination is a special case of labeling where you're choosing. What is the keyword here? Choosing. For example, you are choosing 2 stocks, the combination of 2 stocks out of 3 stocks. So total n stocks. Out of that, you're choosing 2 R. So whenever you have to select or choose, at that time you use combination or permutation. Am I clear?
Yes.
So the keyword for factorial is arrange. The keyword for labeling is arrange in particular category or label. Clear? But the keyword for permutation and combination is when you want to choose or select, right? So you'll always have the word choose, or whenever you have choose or arrange, or you have choose or arrange or select. If they tell you to do that in a rank, then it is permutation, where the order is important. Clear? But if they don't give you any rank or something, then the order is not important, and then we go for combination. So whenever the order of selection is important, then you go for permutation, where they will give you some categories or ranking. But if the order of selection is not important, you go for combination. Fortunately, you don't have to do the formulas here. However, the only difference between permutation and combination is that in the denominator, you have R factorial. So if you take permutation and you divide that by R factorial, you get combination. Correct? So I've done here. If you take the permutation and divide that by R factorial, you get the combination. Everyone with me? Now, let's try that in an example, and you will identify and tell me which one is permutation and combination. Okay? Ready for it? So, here you are given, suppose an investment committee wants to reward 3 analysts out of 7. How many total analysts do you have? How many total analysts you have?
7.
7. Out of that, you are going to reward 3. So you are going to choose 3 out of 7. Clear?
Combination.
Now, I don't know whether the ranking is important. Now they have that's what I have to read. So in the first part they have given, they want to declare who is best, second best, and third best. So now best, second best, and third best. Can I say in this case, guys, the ranking or the order is important?
Yes.
Yes.
So whenever the order is important, what do? We use
Permutation.
permutation. Clear? And how will I solve permutation, guys? I have to find 7p3, isn't it? Correct? These will be the number of ways, and the formula. Now, honestly, you have directly that in the calculator. But if you just want to put the formulas, what will be the formula, guys? It will be 7 factorial divided by 7 minus 3 factorial. Everyone with me? First, let's put the equation and then do the calculation. What is in part 2? In part 2, they have said they want to select 3 analysts who will be rewarded without ranking. Now, there is no ranking. So, is the order important?
No.
Then we use
Combination.
Combination. And what is the formula of combination? In combination, I will use 7c3. Now, I will use 7c3. Which is 7 factorial over 7 minus 3 factorial into 3 factorial. Clear? That will give me the number of ways in which this outcome is possible. But in order to do this, I don't have to manually do it. For 7p3 or 7c3, first of all, before doing the calculation, will the answer of combination be bigger or permutation will be bigger? Permutation, because the order is important. So it always has more combinations than the normal combination, right? So when you go to your calculator, guys, NPR and NCR is in minus and plus. You see that? Minus and plus just behind that. NPR and NCR. NPR is for permutation and NCR is for Combination. Clear? Everyone? So how are you going to solve it? Press 7. 7. First, let's do the combination. Second plus. Second plus. After pressing 7, press second plus. And how many were you going to arrange, guys? 3. You were to give 3 ranks, right? So now press 3 and equal to. And let me know your answer.
35.
35 is the number of combinations, right? So you press 7. So I can say there are 35 combinations possible. So 35 ways. In 35 ways, you can arrange them. However, when you go to permutation, you will again go to the function. Now you'll press 7, but you'll press now second minus. Second minus, because that's permutation. And 3. 7 second minus 3 equal to. And you will get an answer how much?
210.
210 ways. Clear? So quickly tell me, if they give you a keyword called arrange, just arrange, what are you going to use? Factorial, correct? But if they tell you arrange with some category or label, then you use the concept of labeling. What is the factorial concept? You just use x factorial. Labeling, how do you use labeling? In the numerator, you have n factorials, the number of, and in the denominator also you have different types of factorial. So you have n1, n2, and so on. So here you have n1 factorial, n2 factorial, and depending on the number of categories you have. And now if they tell you to choose or select something like this, and in that case you have 2 outcomes: order not important, order important, something like rank. In this case, what are we going to use? When the order is not important, guys, what do you use?
Combination.
Combination. And when the order is important, you use permutation. Clear? Combination is nothing but NCR. Permutation is NPR. Clear, everyone?
Yes.
Any doubts, anyone till this point? Right? Just look at the index. What all things we have covered? So we have covered the concepts of counting problem, where we did, where we understood what is factorial and labeling, and then permutation and combination. Most of these functions are, almost all the functions are there in your calculator. You don't have to manually do or remember it, but you just need to know where to apply it. Is that clear, everyone? Right? Well, that's the end of one of the longest topics of quants, that is probability. A very important topic. What I would want you all to do is a proper revision of this topic. So your reading 7 is done, your reading 8 is done. Of course, reading 6 is done and tested also. So now you'll have test for reading 7 and then reading 8 as well. I'll discuss more details about how and when the test will be later on. But this is where the end of reading 8 is. Now, the important thing is that the next readings, that is reading 9, 10, and 11, they are connected to this reading. So it is very essential that you revise this and then we can do the next reading. So whenever now you approach, whenever we start now the next reading, this is the next reading, that is what we have, common probability distribution. So for that, it is essential that your previous reading is done very correctly, because I'm going to use all those terms quite often. I'm going to use normal distribution and standard deviation and risk and all these terms very frequently. So for that, it is essential that your previous readings are also done properly. Correct? Well, That's it for today's session. So we'll start the new reading in the next session. So now any doubts you have, please let me know. Okay. Yes, go ahead.
In statistical concepts, I had a question regarding the positive and negative
Your
skew.
voice is cracking. I think your earphone is not plugged properly.
Can you hear me now?
It's a bit disturbance, but it's okay. Go ahead. Just let me know.
For the positive skewness,
Positive skewness. Okay, let me go to the skewness. Yes. Yeah, tell me.
can you just explain once more for the positive uh, about the frequent small losses and few extreme gains?
Okay, fine. So just look at the diagram. What is the situation there? First of all, the curve is tilted on the right. That's why we call it positive, right?
Yes.
But if you see the tail is becoming thinner and thinner as it is going right.
Yes.
That is called the probability. The probability is small. It is getting very smaller and smaller of more and more gains. So the more extreme it goes, the thinner is the probability. Correct. So now read it that way. There are extreme gains possible, but are there too many? The probability shows very small, thin.
Okay.
So extreme gains are possible, very low probability. Okay, because you see the curve, the tail getting thinner and thinner. It getting on the bottom side more. A tail. Right in the center, you have maximum probability. That's why in the center you see the peak of the mountain. The mountain is slanting near the tail, but the tail is very far on the right. So when the tail is going on the right, I can say there are possibilities of extreme values, but the possibility is very low. So just think of it like let's say people are giving exams, right? Let's say the average mark is 50. Now, are the extreme marks possible? Will someone get 100 marks or someone get 0 marks? Yes, that is possible. Let's say if I say there are 100 marks or someone getting 100 marks is also possible. But that is extreme value, right? 100 marks.
Yes.
But the possibility of that is very low. So extreme gains, but low probability. Correct? That is positively skewed. Similarly, negative skewed, if you see extreme loss, that is 0. Extreme, but the probability is low.
Okay.
Correct? In a normal distribution, the probability of getting above 50 and below 50 is same. But in a skewness, the possibility of value extreme is high. The amount can be on the extreme side, but the possibility will keep on getting reducing the more and more extreme you go. It's not equal probability, unlike normal distribution. So see the curve of that, see the slanting position of the tail. The extreme it goes, the thinner is the chance, the lesser is the chance. So I generally tell this as an example of what happened in 2020, COVID. Will COVID happen every time?
No.
It's an extreme situation, right? Extreme loss. Extreme loss means extreme bad value. But the probability is very less. If I say out of 100 years, the probability is not even 1%. But
okay.
Extreme
And the tail is
low probability.
okay, and the tail is very high towards the left side.
That's what I discussed. The COVID scenario is left skewed or negatively skewed, where there are extreme negative values possible, but the probability keeps on getting reduced.
Okay.
So a few extreme loss, Why do I say few extreme loss, but few? Because the possibility is low. Clear?
Yes.
Okay. Yes. Any further doubts or anything? Do read the reading number 9, and if you have any doubts across that, please call me up. But complete the reading 9, so when we go to the next session, you all are well prepared for it. Okay. Any
We will
questions? Yeah. Yeah.
for the
Correct.
okay.
Okay. Any further doubts? Do let me know. Or we meet in the next session.
Yes.
Okay. Yes. Thank you, and see you all in the next session. Bye-bye.